going to move on to another skill or technique of factorization, which is factorization by grouping terms. Okay, at this stage, you should be able to factorize by a common factor, by a difference of two squares, and you should be able to factorize trinomials, right? Because factorization by grouping requires you to know how to factorize by a common factor, how to factorize by a difference of two squares, and also how to factorize trinomials. Right? So I'm going to start with a simple example. So let's start with A1. You have Px plus Ky plus Px plus Ky. Right? Now, this one here, if you want to factorize it, you must look at your terms, starting with the first two. Do they have a common factor? There is no common factor. Right? The moment the first two terms don't have a common factor, it should be a clue to you that, or if you can't factorize the first two terms, it means you have to rearrange the terms. Okay? So here I'm going to move term 3 to the second position, and I'll move term 2 to the third position. Okay? That's how I'm going to factorize. So I can write this as Px plus Px. Okay? Now, I'm sure you can see that they are going to be like terms plus Ky plus K1. Okay? Now, you don't have to always rush to just factorize. Sometimes you just have to add the terms or subtract the terms. Since the first term and the second term are like terms, I can add them and I'll get 2px plus 2ky. Okay? Now that I've added them, I can't simplify them further, but I can factorize now. Okay? And we're going to have a common factor there, which is a what? A 2. So this will be 2 times px plus k times 1. Okay? And that will be the final answer. Okay? The instruction says factorize fully. So I factorize there completely. Yes?
So when you are factorizing the px and px, you're not supposed to write an exponent of 2 by x.
We are adding here. If you are adding, the exponent doesn't change. The exponent only changes when you multiply the terms. Okay? We are adding here. So the exponent remains the same. So the first term, this one here, the first term and the third term, they are like terms because both of them have got a p and an x. And the exponent of p is a 1, the exponent of x is a 1. Since we have addition of terms, we just add the terms. That is, add the coefficients. Okay? Don't do anything to the exponents. Right? And let's move on to another one. Which one? Okay. Number 2. So let's do number 2 here. So you have got Rx minus Ry plus Tx minus Ty. It's almost the same as the first one. Okay? But the thing is that you don't have like terms that can be added. Okay? So if you look at the first two terms, there is a common factor. Okay? And that common factor is R. Right? So that would be R. If I take out a common factor for the first two terms, I'll get R times x minus y. The moment you create this binomial factor here, x minus y, be aware that for the last two terms, we must also create a similar factor, which is also x minus y. So the last two terms have a common factor, which is t, and then the binomial factor will be x minus y. Right? Once we get there, it means we are going back to factorization by a common factor, which was the first technique of factorization. Right? So this becomes x minus y. I'm taking out the common factor times r plus t. Okay, I expect you by now to know this. Okay, in this class, I don't expect you to have issues with factorization by a common factor. Right? So that's number 2. Now let's move on to more complex ones. Right? Let's move on to say number 9. Okay? So number 9 is 3ax minus 3ay. So it's 3ax minus 3ay minus x plus y. Right? Okay. Now, first, analyze the expression you are given. The first two terms, we have a common factor. That's 3a. So if I factor out 3a, okay, to get the binomial factor, you should know by now that you divide the first term of the original expression by the common factor. So you have x there. Divide the second term by the common factor, you get minus y. The fact that I have created a binomial factor x minus y means that for the last term, I must also create the same factor. So to end up having a minus here, I have to factor out negative 1. If I factor out negative 1, I'm going to write it here, times x minus 1. Okay? It's always wise to write that invisible one, okay, in case you can get confused. But if you can remember it, don't write it, right? So this becomes, now we are going back to factorizing by a common factor, so this will be x minus y times 3a minus 1. So I factorized that expression completely. Okay? It's not very complicated. Factorization by a common factor and by grouping 2. So I cannot treat you like you haven't done this before. Right? So I want you to factorize number 14. Just write class exercise in your maths workbook, write class exercise, then you copy down number 14. 3x to the power 4 minus 3x squared minus 27x squared plus 27. It's a class exercise. Okay, I'll give you about 2 minutes maximum. Remember, you're supposed to factorize completely. Okay? You can factorize, but not completely. So here you're supposed to factorize completely. Which means you might need to use more than one technique. Okay? For a complex expression like that. But I also want to do that question. I want you to be aware that from today we are going to restart what's called the math platform. We have stopped it due to COVID in 2020, right? So the math platform is more like an extra lesson in course, right? Whereby the math department has got a specific room where you can go Monday to Thursday. So do maths. There will be a teacher there. There will also be some learners who are called academic tutors. Okay. So if you've got any math problem, you can go there any day, Monday to Thursday. Okay. But the teacher won't be teaching. You go there with your own way, right? You do your work. If you've got any challenge with that way, you raise your hand, they will help you there. Okay. Don't expect it, don't go there expecting to be taught like how I'm doing in the lesson. There's no proper teaching there. It's one-on-one. Okay, you get assisted one-on-one. So you can also utilize that as well. So the teachers rotate, and the academic teachers also rotate. Today is my turn. I'm gonna be there from 2:30 to 3:30. And tomorrow there will be another teacher. It's in Miss Van Wyck's classroom. So if you go there, my register will be there. You just go there and then they will mark a register to indicate that you also attended. Okay. I encourage you to utilize that privilege you got. All right. Have you finished? Okay, I want someone to just recite the question for me. Tell me what's the question. Number what? 43. We expect minus 27x. X squared of 27. Really? There's an x squared there. Are you sure? Is this a square? Right. So first thing obviously means the second term and the third term they are like terms. Okay? So you need to simplify that first. That's my suggestion. So the question becomes 3x to the power of 4 minus 30x squared plus 27. Okay? You can do it this way. Right. But now, the problem is, once you do it this way, you need to be aware that to carry on here, we might need what's called a substitution. Okay? But look at it this way. If I take out a common factor for the first two terms, okay, it's going to be a 3x squared. You see that? Also, I can take out a common factor including the 27. It means if I take out a common factor throughout, I'll be left with x to the power of 4 minus 10x squared plus 9. Right? Now, what that means is if I want to factorize this question here, it's not a good idea for me to simplify those two terms. Right? It's not a good idea. The main reason why it's not a good idea is because of this x to the power of what? 4. So it means I have to go via a common factor without simplifying. So the first two terms, if I take out a common factor, it's going to be 3x squared. Right? So I can write that 3x squared times x squared. Right? Minus 1. Okay? Once I create this binomial factor x squared minus 1, I also need to create it between the last two terms. So that will be minus 27 times x squared minus 1. Okay, now you need to be very careful when you've got a complex question because sometimes it can be factorized in more than one way, but among those ways there is only one best way of factorizing. As you saw when I simplified these two, okay, I created a trinomial, but that trinomial is complex. It's not that easy to factorize. So I realized that okay, maybe I don't need to simplify the two middle terms. Yes. Yes, because here the objective is to create a binomial factor which is x squared minus 1. Right? So if I want to create it, it means this positive here must become what? A negative. So the only way I can do that is to factor out minus 27. If I factor out minus 27, it means inside the bracket, I'm going to have a positive x squared and a minus 1. Remember, this binomial factor must be your guide in terms of how you factorize these two terms. Okay? The first binomial factor must be a guide to you that, okay, since I got the first binomial factor as x squared minus 1, it means the last two terms, one of my, your binomial factor must be what? X squared minus 1. How can you get it? Take out negative 27. Okay? If you divide minus 27x squared by minus 20, you get this x squared. Positive 27 divided by minus 20, you get minus 1. If you remove the brackets to go back, multiply minus 27 by x squared, you get this. Minus 27 times minus 1, you get positive 27. Remember, factorization is the opposite of products. Products and factorization, they are related. Right? I hope I answered it. Right? Then, the next thing now here is, let's take out the common factor, which is binomial. So this becomes 3x squared. I'm just going to write this 3x squared as that minus 27 first times x squared minus 1. Now, you must ask yourself, can both binomial factors be factorized? The answer here is a yes. Both can be factorized further. That's why the question is saying factorize what? Fully. So, I think it's better I go to the next page. But I think I can do it down there. Okay. Let me do it down there. Okay. So, the first binomial factor can be factorized. If I take out 3, okay, I'll get 3 times x squared minus 9. Then x squared minus 1 is a difference of 2 squares, so that would be x plus 1 times x minus 1. Remember, we factorize by a difference of 2 squares. Now, this x squared minus 9, is a difference of 2 squares. So it can also be factorized. So if I factorize x squared minus 9, I'll get x minus 3 times x plus 3. Okay? So in the end, you are going to have 4 binomial factors and 1 monomial factor outside, which is going to be a 3. Okay? Then, but is there any question about that? I wonder what answer you got. Huh? So the final answer will be 3 times x minus 3 times x plus 3 times x plus 1 times x minus 1. This will be the final answer. Or maybe it can be 4 or 5 marks because it's quite long. Yes? Sorry? It's out of 50. The investigation is out of 50. Okay? What really that you should know is, okay. Is there anybody else got a question? Any question? Okay. So we don't have a question in the next room. Okay. Let's do another one before I introduce a new method of factorizing. Can you do number 15? I'll give you homework by the way. Number 15. Number 15 is a minus b plus ab minus 1. A minus b plus ab minus 1. It's also a plus exercise. Please, if I give you a lesson, you need to try it. It's fine if you get an incorrect answer because I'll go over it. So you can learn from your mistakes. Okay. So by now we should have done it. Okay, so number 15. Okay, can someone, it's what? It's A. Minus 1. Okay. Right. So that's your question there. So before